Atomic structures have innate properties. When igniting chemicals in a fire, sodium exerts a yellow flame, potassium is lilac, copper is blue. Proxima Centauri is rich in magnesium, Vega has 1/3 metal content, Sirius has 3 times as much iron as Earth. These specific statistics give stellar bodies their implicit characteristics of light and can affect the observable redshift. If the redshift is entirely or partially non-Doppler, that is not due to cosmic expansion, then it could be an intrinsic property of a galaxy, as basic a characteristic as its mass or luminosity. David Plaisted, UNC. Gases can spread and are malleable and come in different colors and change unexpectedly, which could cause a shift in observations of a star moving away through gas, or is partially mixed with gas, or it can affect the star's initial measurement, causing a perceived redshift. In regards to cosmic redshift and blue shift and light being a constant that are so integral in proving the existence of galaxies moving away, the cosmic microwave background, and the Big Bang, there is a contradiction in the explanation of the data. Light has different wavelengths and frequencies associated with it, and by definition, it cannot remain a constant. There is a stretching of frequencies and wavelengths throughout the cosmos, coupled with the myriad of dust clouds, angle orientation that causes sunsets and sunrises, gravitational pull of other stars, and different implicit color observations of redshift or blue shifts that change and refract. According to Wikipedia, gravitational blue shifts are associated with light emitted from a source residing within a weaker gravitational field as observed within a stronger gravitational field, while gravitational redshifting implies the opposite conditions. Given that there are different speeds of light in the universe, different wavelengths, different frequencies, and given that the theorem proposed by Albert Einstein in special relativity, length contraction, is true, length contraction is an effect that a majority of the cosmological intellects believe in. The theory states that the closer an object goes to the speed of light, the shorter the object becomes. An object simply means a distance with endpoints that are always mutually at rest. Wikipedia. If by definition light is a particle and therefore has endpoints, it would be considered an object. Length contraction could then be applied to it. If this principle holds true for light particles, it could hold true for waves as well, because of wave-particle duality. From what we know of the double slit experiment and photoelectric effect that proves that light could be a wave or a particle or both, the faster the light particle or neutrino goes towards the speed of light, the more its length could contract. If wave-particle duality exists and the light is going then at light speed, then by that definition the light's length should contract as well, and we should see a shorter wavelength that appears blue shifted, not the observed redshift. This concept, to my knowledge, has not been observed in practice. History and experiments. Historically, the Big Bang theory of the cosmos and redshift has been around since the first Doppler redshift was described by French physicist Hippolyte Fizeau in 1848, who pointed to the shift in spectral lines seen in stars as being due to the Doppler effect. A myriad of different experiments have been done to measure this, the pillar of modern Big Bang cosmology, which is essential in defending both Edwin Hubble's observation of galaxies moving away and the cosmic microwave background. Projects like BICEP, background imaging and cosmic extragalactic polarization, and the Keck array are a series of cosmic microwave background experiments. They aim to measure the polarization, the difference in temperature of the CMB, in particular measuring the B mode, which are detectable gravitational waves in the early universe. In the Hulse-Taylor experiment, they detected radio emissions from a binary star. After timing the radio pulses for some time, Hulse and Taylor noticed that there was a systematic variation in the arrival time of the pulses. Sometimes the pulses were received a little sooner than expected, sometimes later than expected. These variations changed in a smooth and repetitive manner, with the period of 7.75 hours. They realized that such behavior is predicted if the pulsar were in a binary orbit with another star, later confirmed to be another neutron star. Wikipedia. There is the possibility that the radio emissions time intervals were obstructed by a combination of the binary star's gravity and/or cosmological constant reading, or it could have been gravitational lensing of waves by a gas cloud, ether with less continuity, or the possibility that the emissions, although not human-made, could have been emitted simply at random, which are all reasonable hypotheses of why they were detected in the manner that they were. Another experiment relating to redshift is the Pound-Rebka experiment, which was a measure of a photon moving in a gravitational field. This experiment has implications in time dilation and gravitational lensing of planetary bodies. The Pound-Rebka experiment, which they use the equation change in wavelength divided by wavelength is approximately equal to the gravitational constant on Earth, with a change in the y and x variables divided by the speed of light squared, where the change in y is a change in height in which they observed the difference in gravity. The energy associated with gravitational redshift over a distance of 22.5 meters is very small. The fractional change in energy is given and is around 2.5 times 10 to the negative 15th. Therefore, short wavelength, high energy photons are required to detect such minute differences. The experiment measures emitted photons of iron-57 atoms upon excitation. It recorded a conclusion of when an emitter was placed 73.8 feet apart at a north and south location. There was a recorded frequency shift of redshift and blue shift inside a natural gravitational field. They adjusted the emitter to send the excited gamma rays produced by the iron atoms from the roof to the basement and then basement to roof. The baseline emission of gamma ray photons of wavelength of 1 was measured on the roof as having a wavelength of 1.0000000000002455, and the roof emitted gamma ray of wavelength 1 was measured in the basement as having a wavelength of 0.9999999999999997755. This was proof that the gravitational field affected the photon and recorded its red shifting and blue shifting in short distances. They also concluded if the two systems are stationary relative to one another and the space between them is flat, neglecting gravitational fields, then the photon emitted by the emitter can be absorbed by the electron in the receiver. However, if the two systems are in a gravitational field, then the photon may undergo gravitational redshift as it travels from the first system to the second, causing the photon frequency observed by the receiver to be different to the frequency observed by the emitter. The Pound-Rebka experiment. Wikipedia.